Otis asks, when Alex, Curtis, and Michael go boating together on a calm day, they leave the marina dock and travel at a speed of 40 kilometers an hour due east for 3 hours. So let's symbolize due east by this direction, because usually it is east, south, west, north. So using our cardinal directions, we know that this is north, this is east, and this is south. And I'm not going to draw west, but know that it's this way. They go due east for 40 kilometers an hour at 3 hours. For 3 hours at 40 kilometers an hour, which is 120 kilometers, just multiplying out their speed by the time that they traveled at that speed. Then they travel 22 degrees west of south. So if we were to draw south here from the point where they change direction, they travel 22 degrees west of south. So a line going in about this direction, and they travel for 2 hours at a speed of 30 kilometers, which results in 60 kilometers traveled. So these units are in kilometers, but I'm not going to bother with that right now. The angle that would result from this, right, is going to be a 90-degree angle, because that's east to south, minus 22 degrees, because that's going to be the inflection of the angle. So that is going to be an angle of 68 degrees. And I'm just going to write that in here, that theta is equal to 68 degrees. Let's do this in the equation editor. 68 degrees. All right. So we have this 68-degree angle. We have these two distances. And we have to find what is the how far must the mechanic travel to them from their starting point, and in what angular direction. So the first thing we can find here with the cosine rule is the distance. We know for the cosine rule, we have to start labeling a few things. Let's call this side length C. Let's call this A. And let's call this B. This is going to be the angle of C, which we can call theta of C. And then we can use the cosine law, which is that C is equal to the square root of A squared plus B squared minus 2AB times the cosine of theta C. So plugging all of these values into our calculator to find the side length C, we find that C is equal to a side length of 112.27 kilometers. Now, it's a bit more precise than that, but I've rounded it down to 2 decimal places. Now that we know the side length here, that this is equal to 112.27, we can use the property of sines, the law of sines, to create a proportionality between this angle, let's call this theta of B, and this is the side length B, and this is theta of C and the side length C. So according to the sine law, the sine of 68 degrees, which is our theta C, over the length of the side C, which is 112.27, pardon my handwriting, is equal to the sine of our angle x, which is this theta b, over the side length of that corresponding side, which is 60. Rearranging this, we can find the sine of x, which is equal to 0.495, etc. And using the inverse sine function on your calculator, you should be able to calculate that this x, which is just theta b, the direction they have to go in terms of an angle of this triangle, is going to be 29.7 degrees. That is their direction relative to east that they're going to have to go. And so usually when we measure angles in a circle like this, the angle is relative to due east, but it goes this way. So that north is 90 degrees. Due west is 180 degrees. South is 270 degrees. And back to due east is 360. So if we want to tell the mechanic which direction to go into, relative to a unit circle like this, we're going to tell him 360 minus 29.7. So 360 minus 29.7 is going to equal 330.2, 29, well, that's going to be 3.3 degrees. That is going to be the direction in which the mechanics have to go, and 112.27 is going to be the distance they have to travel to get to Alex, Curtis, and Mike as their boat has broken down in this location. Nice combination of the cosine and sine rules in this one. I really enjoyed it.